Now we are in the last part of our analysis. We've created our cost raster that we're seeing here. We're modeling, or we're seeing in the raster calculator the most suitable locations, preferable locations for me to walk are in the dark black and in the lighter whites. They're less suitable. Now that we have gotten this far on our model, we've gotten all the way to the raster calculator. We're going to start with some of our cost distance tools. Believe it or not, before we get to the cost path tool, we still have another tool to go. That's our cost distance tool. This tool calculates the least cumulative cost distance for each cell to the nearest source over a cost surface. So it's telling us how far away from the origin we are from our source, which for us is our turn back on. Starting point over here as we move across the cost surface. So in every direction across our cost raster, it's going to be looking for how far it is. What's I going to say about this? This will produce some outputs that are a lot like our flow direction tool and flow accumulation tools, because it's assigning the cell that cost. Unlike the flow direction and flow accumulation, there are impedances, there are things that are going to be influencing which way we move across the raster besides just distance. So those are the costs, and for us, in this example of hiking across San Diego, all the costs are related to my preferences. So let's go ahead and look at this tool. Our input is the input should be our raster calculator. I'm not sure why it's saying the lane cover data set. Oh, input, the input source locations. Okay, so that's our source locations. So we will find the source. Input cost raster. We have that our raster calculator, and we renamed our outputs output distance raster, which is one of our outputs distance, and our output backlink raster direction. Let's run that and we'll talk about what those results mean. Let's take a look at those results. You can see we have our distance output, our cost distance raster, and our direction. Let's take a look at those results. We'll have our direction output and our distance output. Let's start by talking about the distance output. So remember, we are trying to figure out on this whole analysis, cost path, is trying to figure out the least accumulative cost to your source from the destination. So the cost distance tool is a lot like our Euclidean distance tool because it's measuring distance, but with our Euclidean distance, you're measuring straight line distance from one location to the other. Our cost tool is determining the shortest weighted distance, or that travel cost, from each cell to each cell. So instead of just going across in a straight line, it's going cell to cell, so you have those 8 different directions you can move around your cell. So we're not looking at distance in terms of linear distance or meters or miles. We're looking at distance in terms of cost. So we're seeing that distance and how far away or close something is based on the least accumulative cost over the surface. Our other, one thing I want to show you, a lot of times you'll see this in examples displayed differently. It won't be in that black and white weird formulation. And with the scientific notation, you'll probably see it similar to, something like this in ArcMap. So our other output here is our direction. And like I mentioned before, the backlink or backlink output or cost backlink output that I call the direction output is a lot like the flow direction in that we're using that the values that we're seeing here, 0, 1, 2, 3, 4, 5, 6, 7, 8, are placeholders for the direction that we're moving across the cell. Direction towards the neighboring cell with the least cost. So we can take a look at this green cell here, since this cell has been assigned the number 2, or lower right. This tells us that the path is to pass to the lower right, so heading down on this diagonal. What else do we need to know about this? So I think that is it for our 2 outputs here. Now we've done our cost distance, now we can do the cost path. So far in this analysis, we have, let's zoom out to our whole model, calculated the cost of travel over our surface. We've added in those characteristics of the mover using the raster calculator. And now we're figuring out the movement characteristics on the surface. So we did that with the cost distance and cost direction. Now we can do our cost path tool, which we can open up and see the analysis. So we have input raster, feature, destination. Data is not going to be any of these outputs. It's going to be our destination. I want to make sure it's pulling on the destination here. Where'd it go? Destination. Okay. We changed the output raster, just change the name of that, and leave a path type to each cell, because we're just doing one source and one destination. And we can go ahead and click OK, and then I'll get rid of this one and save. And we can go ahead and run, and we'll see if that changed. Yeah. Okay. Let's get rid of this. Let's try instead. We are just going to try pulling it. Oh, oops, that was distance. That's not what we wanted to do. Nope, okay. Okay, so I'm just going to pull destination onto our canvas and then, oops, draw the arrow into cost path and set this as input raster or feature destination data. Now I'm going to try to run this again. Why is it not? Field value does not exist. Okay, so troubleshooting that first error, making sure that the destination field is set to object ID. Try to run it again and see if that fixed it. Looks like it did. Okay, so we can add, this has been added. Okay, turn this off, turn this off. Back up so we can actually see what we're looking at. So now we can see that we had, as a result from our analysis, a one cell wide path that goes from our source to our destination. It is a raster data set, so that's why you're seeing why I can't just make it larger right now, because it's just that one cell wide. This 1 to 3 is coming from our example here, where we set up our relative weights. So since we have our assigned rank 1 to 3, it will assign the least cost path that 3 value. You'll notice I have another step on here, polyline, raster to polyline, and this is basically setting it up so I can do a little bit more with it. And we can see now we have a line, so I can change the symbology so you can see it a bit better. Change that to a little bit brighter. I'll just make it red for now. So you can see that this is determining the least cost path based on my preferences. Something we talked about in class last night was this was a good start, but maybe not the only choice. This got flipped around. See in the dark areas. This is a good start, but maybe not the only choice. We saw problems where it was directly along the 15, so I want to make sure that I want to take a look at this area here and see if I need to adjust my model to better model where I want to walk. You know, the line is technically right next to the freeways, but you're seeing that it's pretty close. So now the time, what you would be doing if this was your project, or if this is a real project to create a hiking path across the county, that would be doing things to validate the results. So talking to other people who know the hiking paths better, perhaps communicating with some of these, there's the wetlands here, making sure that this is on the path in the wetlands. Actually, that's something I want to do. Let's see where there are paths. See, it's important. Anyway, if there are paths in the wetlands, which it doesn't look like it came up, but making sure it's hitting those paths. I'm seeing maybe where we need to maybe edit the trail a little bit. Obviously, it would be great if we could do the whole hike to test it out and figure out what works and what doesn't work. But that's the general idea of how you get started on your least cost path.